So I have a great deal of books on computing in general, really, database systems, computer architecture, networks, maths, physics, and even some personal books there, which you can feel free to pause and judge. But there are some books that always stick with you and stand out more than others, and that is this book, Operating Systems, 3 Easy Pieces, written by Remzi and Andrea Apache Dusso. And I do apologise if I butchered that surname. They're both from the University of Wisconsin, and the book is completely free for you to download online. And that's all you need to know. You can end the video right here. If you want to learn operating systems and you're a beginner, you should pick up this book, even if you're not a beginner, even if you're a university student who wants to just tweak bits, refine on your operating systems knowledge, and also connect the dots as well, okay? Now, I love this book so much that I bought a physical copy. This book is fantastic, and I really wanted to support the authors. The book is free online. They've made it accessible for anyone interested in learning operating systems or computing in general. So I can only encourage you guys to just support them if you can, if you're fortunate enough, because the book is that good. I'm going to go over this book. We'll have a little look at the contents of this very shortly. But before I do that, I think it's really important that I talk a little bit about why it is I think you should get this book and what this book means to me. And to do that, I have to give you a bit of context. I'm a past computing student, so I've studied computing at a university level. And then after that, I went into secondary education and then transitioned into higher education. And before I knew it, an operating system module was up for grabs, and I fought tooth and nail for that module because I'm really passionate about operating systems. I find them interesting. I find it a fun topic to teach. But that being said, it's a very, very complex topic. Now, for those of you who don't know, Operating Systems 3 Easy Pieces is a play on Richard Feynman's 6 Easy Pieces, which I have right here. So this is Richard Feynman's 6 Easy Pieces, okay? So it's literally a play on this book here, okay? This book is breaking down physics, a very complex subject, into bite-sized topics which will help you understand physics as a whole effectively, okay? Now, is it in 6 Easy Pieces? Take it with a pinch of salt. Read the book yourself, you'll find out. But those of you who are keen, I would have seen this on my bookshelf, and that is effectively what 3 Easy Pieces is based on. So it's trying to effectively take a complex topic and break it down into bite-sized kind of subtopics that will make, hopefully, the whole concept of operating systems much easier for you to learn. So there we are then. That's effectively all the book is doing. It's taking operating systems, a very complex topic, very much like physics, and breaking it down into 3 easy pieces, okay? Now, when I say pieces, those 3 pieces are quite literally virtualization, concurrency, and persistence. And they've also added security in, and the inside joke kind of is to do with Unix, the fact that security was added later, much like it was with Unix, okay? Now, this book is phenomenal, and the amount that it covers in the way that it does is fantastic compared to these 2 books, which I'm about to show you right now. But before I do that, there's just a little bit more context I need to give. Operating systems, there are thousands and thousands and thousands and thousands of good books out there on the topics, okay? But there are some that do it better than others, and those 2 books that I'm going to mention, okay, alongside this book is Silberschatz's Operating System Concepts, and also Modern Operating Systems by Tannenbaum, okay? So these are both absolutely fantastic books, and they are timeless, okay? They're not going anywhere. The content of operating systems really hasn't changed much in the past 20, 30 years, okay? That being said, there are some books that do it better than others. Now, some of you at this point might be wondering, well, how is it that you know all of this? How do you know what books are good and bad in terms of operating systems if you've only been teaching the module for the past year? And the honest answer is, I don't know with absolute certainty. But what I do know is that there are a lot of knowledgeable people out there online, and I read countless of blog posts and Reddit posts and such like that when it came to prepping for this module, and I decided to go with what I thought was the best guess. And those 3 books, Operating Systems 3 Easy Pieces, Operating System Concepts, and Modern Operating Systems, were the ones that stood out to me. And not only to mention, one post that stood out the most to me of all of them was an operating system professor. Okay, so somebody who does research in operating systems, much like Remzi and Andrea, if you've got their names there, do themselves. Okay, so they're operating systems researchers, okay, and I think those are the best types of people to learn from. But this one particular operating systems professor talked a little bit about why this book is so good, and I couldn't agree more when I picked up the book. First of all, it's a book that you will not want to put down, okay? So literally when you start it, it assumes that you have very little understanding of a computer. Okay, what makes a computer? The von Neumann architecture, the fact that you fetch, decode instructions, and so on. Okay, so that is very, very nice, and it literally teaches you operating systems from the ground up, which is really nice. Even if you know a lot about operating systems, or you've got this like selected knowledge. For example, you might know a little bit about. Let's take an example here. You might know a little bit about scheduling, but you might not know a lot about concurrency and threads, or you might know a little bit about how processes work, but you don't know the underlying mechanisms that make processes switch between each other. Okay, so that is why this book is fantastic. It's almost got like a spiral curriculum approach to how the book is structured, and I think that is absolutely fantastic if you are somebody right now who has no understanding of operating systems. So moving on, I'm going to show you a little bit about the book. I've got my phone here. I'm going to do a little bit of a recording about the different contents in that book, and we'll chat a little bit more about that. Right, so this is what the book looks like in person then. It's the physical copy, and it is a fantastic book. Like I've mentioned, it's a thick book, so there's a lot in here, but the pages are quite small, so you can get through it relatively quickly. Again, in preparing for the module, it really didn't take me too long. The first chapter is a great introduction, so it's going to talk a little bit about how these physical resources are virtualized. Okay, so things like the CPU and memory. Covers a little bit about concurrency, why it's important to have an understanding of concurrency in computer systems, and persistence as well. And then it talks about the design goals of an operating system, as well as the history. So again, this book is fantastic because it's giving you the context, which is really important, and a lot of books don't do that as well as this book, I found. And also as well, it gives you some homework. So if I just jump straight ahead really quickly, you can see that this book comes with a bunch of different homeworks you can complete, so a bunch of different questions for you to try and have a go at, and there's probably answers online that other people have completed them, so if you need help or support, I'm sure that's available online. It might even be available in the GitHub repository. That's something I haven't checked. Some of these I have completed, not all of them. Mainly the C programs I have, but it also comes with some Python programs as well. So for those of you who find C a bit daunting at this stage, then don't worry. There are some Python programs you can play around with as well. So just again, example of one of the questions I might ask you to take on then. So write a simple program called null.c that creates a pointer to an integer, sets it to null, and then tries to dereference it. Compile this executable to null, and what happens when you run this program. So it's kind of like, again, giving you the practical sense. The theory is quite easy to understand from just reading along with this book. And again, it follows almost a spiral curriculum. So you can see I've dog-eared this book many times. Again, it's very useful when you're teaching these topics. But even things like the process API chapters. So there's the process API chapter, there's the memory API chapter, which gives you actual practical examples then of things like system calls. So some of you may be familiar with fork or exec, and I've made previous videos covering these activities, and we're going to have a look at one of those programs shortly in this video. But again, it'll cover loads and loads of different topics. So things like segmentation then, okay, so understanding why seg faults happen, even things like translation look-aside buffers. It talks about address translation, which is an important topic. So how do we convert a program's virtual memory into the physical memory then? So how is that done? And again, it's all practical, and I think that this is a fantastic book and one you should definitely worth investing on. Right, so I thought it'd be good to actually run through that example that we just seen in the book, because again, it's applied, it shows you that something can go wrong, and I'll try and explain it after. Okay, so the example was create a file called null.c, and it asked us to include, well, didn't ask us to do this, but we know we got to do it anyway. So include the standard input-output library, include standard lib, and then once we do that, we're going to create our main function, and we are going to begin the task. So the task was effectively asking us to create a pointer to an integer type. So we'll say int pointer, and we'll just call it pointer, and we're going to set this value to equal null. Okay, and now what we're going to do is ask us to effectively dereference that value. So we use the asterisk and we say pointer equals, and we set it to an actual value after the fact. So let's try doing that, and then all it wants us to do then is printf, and we'll print the integer value of pointer. So as I think that is what it was expecting us to do. I haven't got the book open by the side of me, so I'm assuming that I'm correct there, but effectively all it wants us to do is create a pointer, set that pointer to null, and then try and dereference that and store value in there after the fact. So let's try and do that now. So if we compile this, we'll use clang null .c, and then we'll say call the file null. And if we run this, then we should get what I imagine would be a seg fault, which we do. Okay, so why is it that that happened then? Well, let's take a little look. So quite literally then, the whole point of this program, quite simply, is that it is showing us that we can't set a pointer to a null value, okay? So we're trying to, well, we can do that, but if we dereference it, it's going to cause an error, okay? So quite literally, we are trying to dereference a null pointer, which causes undefined behavior and will typically result in a seg fault then, okay? So this line by here, int pointer null is effectively creating an integer pointer, and we'll explicitly point it to null, which is nowhere effectively, okay? So it doesn't hold a memory address. And then in this line here, we are dereferencing that. So effectively, we're telling the computer, right, go to this memory address, and we are saying store the value 10 in there. But because pointer or PTR is pointing to nowhere effectively, okay, it's attempting to write in an invalid memory zone. So that is the whole point of the program, okay? It's showing us hands-on what we can and cannot do with pointers in C. Now, this is just a small, very small example. I do appreciate that, okay? And again, the book kind of gives you the context leading up to that practical activity, okay? But you get the general idea, okay? We are trying to write to a memory address which doesn't exist, and therefore the program is crashing. Now, very simple example, but I think it just goes to show how amazing this book is. So in short then, the whole reason why I created this video is just to share my thoughts on this book and share how valuable it's been to me in my learning journey and how valuable it can be to you in your learning journey. So I would strongly encourage any of you to go pick up the book. I would encourage you to learn it as much as you can, study it, become a student, work your way through chapter by chapter. I'm due a refresher over this summer period, so I'm certainly going to be picking up this book and making a few notes, and I would encourage you to do the same too. Again, operating systems is not an easy topic, okay? And nobody's going to become an expert overnight. But with a bit of work, with a bit of effort, and through constant learning, you'll get there, I promise. And especially if you learn from Remzi and Andrea Apache Dasso. And I apologize if I butchered that name. If you enjoyed this video and you'd like to see more content, please like, comment, and subscribe. And I look forward to seeing you in the next one. Bye.